Okay, good morning again. This is Professor David J. De Los Reyes. Okay, this will be a discussion on long video format. Okay, my topic for this next session will be an evaluation problem of a differential equation. We're back on differential equation. For those who are taking the SAT exams, this is a different topic. Also, for those who are taking up engineering, this is for you guys. Okay. We are given the problem, evaluate the given differential equation is the quantity x squared plus 1 times dy dx plus the product xy equal to the square root of x squared plus 1 over x. We are asked to evaluate, so we will try to find the general solution. Okay. Okay, let's proceed. The given differential equation falls under the so-called solution by using an integrating factor. And for it to fall under the integrating factor, we must have to make some algebraic manipulations. So if we try to multiply the given differential equation by 1 over the square of x plus 1, okay, this one here cancel with this. It's not so good. Okay, so what remains on the first one after the multiplication will just be simply dy dx. The next one will be the product xy times this. I will combine the pure constant x terms, so I will just place them under one quantity, so this will be x over x squared plus 1, which is this, times y. And this should be equal to the right hand side. The right hand side involves a radical expression, the square root of x squared plus 1 over x, times the multiplier 1 over x squared plus 1. Okay. I want the first term to be dy dx, because if you try to recall, under the solution by using the integrating factors, the form is actually similar to this. Dy dx plus p of x multiplied by y is equal to a cube x. I make the first term dy dx, so I could relate to this one form here. This form here is actually case number 1 under the solution of a differential equation solvable by using an integrating factor. Okay, let's proceed. So after the multiplication of 1 over x squared plus 1, the first term falls under dy dx. So it's getting clearer now. This falls under case number 1 because the first term is dy dx. So we need only to identify now p of x and q of x for it to fall under case number 1. Because under case number 1, the general solution under case number 1 will be y times the integrating factor equal to the integral of a q of x, again times the integrating factor multiplied by dx. Okay? And the integrating factor for case number 1 is e raised to the integral of p of x dx. So meaning to bring out the solution, we need to compute for the integrating factor, okay, by using this equation here. This is the standard formula on how to take integrating factor for case number 1. Okay? Or let's proceed. Or we'll continue with this. So dy dx plus the ratio x over x squared plus 1 times y equal to the square root of x squared plus 1 over x. X squared plus 1 is actually the product of x squared plus 1. This is actually raised to the 2 halves, right? So it can be written as x squared plus 1 loss of exponent to the 1 half times x squared plus 1 to the 1 half. Same base, okay, add the exponent. So if we try to simplify this square root here, it will become x squared plus 1. 1 half plus 1 is actually 2 halves. And what is 2 halves? It's just 1. Okay? So the equivalent of this square of x plus 1 is actually the product of the square root of x squared plus 1 times x squared plus 1. So this one here, cancel this. Okay? I will try to erase this one so it will look like okay? And also with this one. So it will look nice. Okay? Let's continue. So after the cancellation, this will now be dy dx plus x over x squared plus 1 times y equal to, what remains will be 1 over x, the square root of x squared plus 1. This remains on the denominator, and so it is. So it is this. Okay? And this now falls under the equation or form dy dx plus p of x times y equal to q of x, the one I wrote here. So we could identify that p of x is this one, and q of x is this one. Okay? So p of x will be the ratio x over x squared plus 1, and the integrating factor for case number 1 is e raised to the integral of p of x dx. The integrating factor for case number 1 is e raised to the integral of p of x dx, right? P of x is actually the ratio x over x squared plus 1. It is this. So by following this, the integrating factor will be e raised to the integral of x dx over x squared plus 1. Okay? So we are now on the process of integrating. Okay, the integral of x dx all over x squared plus 1. Okay, this falls under natural logarithm where the value of u is x squared plus 1 and du will be 2x dx plus 0. So we lack the value 2 here, so we place 1 half. So this is now 1 half. The integral of 2x dx over x squared plus 1. Okay, continuing, this should now be e raised to, after the insertion of 2, this now falls under the natural logarithm, the integral of this. This is now 1 half the natural logarithm of x squared plus 1. Okay, the resulting integral of the integrating factor. So the integrating factor is e raised to 1 half the natural logarithm of x squared plus 1. But this one, if we try to follow the laws of logarithm, this can be written as the natural logarithm of x squared plus 1. Okay? We put the 1 half on the exponent. Okay? Because if we try to simplify this one, it can be written as 1 half the natural logarithm of this, or simply the natural logarithm of x squared plus 1 raised to the 1 half. And the antilog of the natural logarithm of the given exponent is just the given exponent. This is antilog. Right? E raised to the natural logarithm is antilog, right? So what comes out for the integrating factor will be the square root of x squared plus 1. Okay? So if we now try to bring out the general solution, as I have said a while ago, it's an easy matter. I'll repeat again. The general solution is y times the integrating factor equal to the integral of the right hand side, q of x, right? Again, times the integrating factor multiplied by the x. Okay, this is the form on how to get the general solution under case number 1. So it will now be y times the computed value of the integrating factor, the square root of x squared plus 1, equal to the integral. The right hand side is actually 1 over x square root of x squared plus 1. The computed integrating factor is the square root of x squared plus 1 multiplied by the x. And luckily, this square root cancel with this. So what remains on the right hand side will be dx over x. And this is an easy one. The integral of dx over x, it will be the natural logarithm of x. So our final answer will be y multiplied by the square root of x squared plus 1 equal to the natural logarithm of x plus c. So this will be our final answer. Okay? That's it. For this long video format, this is for those who are taking up engineering. If you are taking the SAT, this is a different one. Okay, I don't know if there is a topic like this on the SAT exam. Okay, good morning from Los Angeles.